Good morning. Good morning. All right. I'm super excited that you guys chose to take advantage of the opportunity to come down and learn a little bit more about our information technology, programming, and design career pathway at St. George's. So if you recall, I came to your classes a couple of weeks ago, and I showed a couple videos about what is coding. You heard from Chris Bosch, you heard from the lead singer from the Black Eyed Peas, and it kind of give you a little bit of overview of how why we need to learn how to code, and we talked a little bit about the industry in general. And again, since I'm not an expert in the field, we brought those who are experts in the field to go ahead and show you a little bit more about what the industry is all about, to see if it's something that you want to apply for during reapplication, because I know you have your reapplication forms in your hands already, and you need to make a decision, most of you, by this Friday. So, I'd like to introduce our guest presenters today. We have Mr. Shaw, professor from Wilmington University. Mr. from Diamond Technology. Mr. Christine, he's from the Microsoft store. Mr. Mancini, he's our district technology supervisor. So again, you're going to hear a couple of presentations, so listen closely, start thinking about, wow, this is something that really intrigues me, I'd like to learn more, maybe this is something that would be a good fit for me. And after the presentations are over, we can go ahead and open it up to question and answer. Does that sound good to everybody?
Yes, sir.
All right. Ready, Mr. Shaw, he's going to start off.
Okay. So, as you've seen on the screen for a few minutes while you're sitting here waiting for us to start, coding and why should you care? Because a lot of times you get into these things and you're like, why am I here? What does this matter to me, right? So, let me tell you a little bit about myself. Yes, that's me sitting on the throne from Game of Thrones. And that was at GDC, or the Game Developers Conference. I run the game design development program and the motion graphics, video motion graphics program, and the maker certificate at Wilmington University. Just out of curiosity, how many of you are familiar with like the maker thing or maker spaces? Okay, one or two. What about 3D printing? Oh, that's cool. What about Arduino and Raspberry Pi? Anybody know about that stuff? What about robotics? Okay, all that kind of stuff gets wrapped up into a maker certificate. So when you hear maker, think of those things, and now you all know. It's awesome. We can check that off our list. So here's why you should care, because a lot of times you get told these things or presented these things, and it doesn't really matter to you. You're just like, why do I care now that I'm in high school? So I did a Google search this morning, and I'm just going to kind of point out some things. 61 million results on why coding is needed. And I'm just going to kind of go into that little shot of the slide. So skills of the future. Most important job skill of the future. Right? So if you're in high school now, you can start preparing for this career now rather than after you get out of college. Or if you go through college and then you're like, oh, I want to become a coder now. Like, folks that are in your position right now have a huge advantage of the folks that are out there in the industry now, because all these new developments, all these new things are going to be run through programming and coding. And those kind of things are kind of interchangeable. So if you have an important job and you work hard, you can make money, right? Because that's ultimately what the goal of schooling in any kind of capacity is, to make sure that your life and your job and your happiness all kind of come together. But a lot of times, in order to be kind of successful, people see money. So you could actually sub out the little dollar signs there with happy faces if you want, because a lot of times people want to make an impact rather than getting paid. But having an important job and hard work is super important. Desired skills plus hard work. So as you saw in those Google results, people want these skills. People are looking to hire folks that are capable of creating things through code. Coding plus hard work. So you notice a theme here, right? What's the consistent thing is the hard work, right? So you could kind of interchange all of that. Like whatever you want to do plus working hard at it is going to give you the result that you want, whether it's the dollar signs or the happy faces. So examples of jobs from programming or coding. Programmer, obviously. What does that kind of break down into? Web development, games, game development. How many of you want to make video games for a living? Awesome, you're my people. I want to see you in a couple of years. Application development. So, how many of you have a smartphone? How many of you? Somebody just dropped their phone. Awesome. So, application developers, like the folks that make the apps that are on your phone, you can go into that. Product designer. You're like, wait a minute, product design. I thought that was like art and hard skills. How does programming and coding go into that? Well, think of anything that you use on a regular daily basis. It's probably touched or came through or been manipulated by or been sold by some form of programming and coding. Robotics, obviously. Cars, self-driving cars, they scare me. Transportation in general, so all of your traffic lights and traffic flow, data around traffic flow, data around where people live, where people work and how they get there. Utility companies, pretty much everything that you come in contact these days comes through some form of technology. And if you can interchange the word technology with programming or coding, you got it, right? So, what does it look like? All right, so this is programming. This is C#. I'll zoom into it a little bit. And this is coming from the Unity game engine. And this is done in a program called MonoDevelop. So this looks kind of like scary. Who gets like scared by looking at this stuff? Okay. The good thing is that it's only text. The bad thing is that it's only text. So a lot of the skills that you're going to develop now, just good concept development of taking an abstract idea and be able to formalize it into steps in order to get there, that's really what programming is. So this is another example of just programming. This is an attack list from a server we have set up at the school called a honeypot. And its sole job is to attract attackers and hackers. And these are all attacks that came in. And you can see they're pretty tightly clustered. You know, it starts at 7:21 a.m. and goes to 7:25 a.m. There's already 45 hits in each thing. So there's a date timestamp, and then the attackers are trying to find an account with those names. So root, admin, user, guest, support. So if you have those as your like username on your personal computers, change them now. And then the IP address of where that attack's coming from and which country it's coming from. So this is dumped out as a CSV or comma separated values list. But this could also be XML or a JSON or all those kind of other funky acronyms that make no sense to you right now. But this is also coding. Anybody realize or recognize what this is? Oh, yes, what is it?
It's like a box code.
Box
Sort
code?
of put it together and make stuff.
Block coding? Yep. Is that what you were going to say? Click and drag, drag and drop. So this comes out of a program called Scratch. So it's kind of like a game engine, and they use code blocks in order to write the same stuff that I showed you earlier. So instead of actually writing it out and getting syntax wrong, like if you put a semicolon versus a colon, like it does different things. And this kind of takes all of the syntax out of it, really just strips it down to logic. And I say, if you can figure out an if-then statement, then you can program and make games. So I used a if-then statement to explain programming. Yeah. All right, so all of these things, programming comes in many shapes, forms, languages, flavors, syntax, all kinds of things. So what does it do? Well, makes games. Every game that you've played, or ever will play, comes out of something that has been programmed. Robotics, they don't know how to do stuff unless you program it to. Until we get to the point where robots take over the universe and they self-learn, somebody has to tell those robots how to behave and how to function. And think about this, that if-then statement. If this particular sensor, let's say temperature sensor, goes above a certain threshold, then do something else, right? So if the robot is told to walk forward, then actuate the servers to make it walk forward. So all of this kind of stuff gets wrapped into just about everything up here. Transportation I talked about, finding out where a plane is overhead, that takes some code. Making sure that buses run on time, that takes some code. Apps, obviously. That's a supply chain graphic. You guys are like, why do I care about supply chain? Who likes to buy stuff? Okay, good. That's why supply chain is important. It explains how, like, where my product is in terms of manufacturing and where it goes out the door. So, like, Walmart's a big supply chain example, but, like, how do you get most of your content these days? Amazon, right? They're, like, big supply chain nuts. Tesla, you think there's programming in that car?
Yes.
Web development, PHP, MySQL, HTML5, CSS, JavaScript, banking. I know, it's great. And then sports technology. So I'm going to show a quick demo in Unity. So Unity is a game engine, but what I use this for, we do live stream of our sports as well in our video motion graphics program. So as people are on our baseball team or our basketball team, which made it to the championships for the first time ever this year, yay, go us, we made these animated scoreboards in a game engine. Like, why would I do that? Well, because I could. So I took all of the graphics and stuff that we wanted into it, wired it up so that if the user pressed F1 or F2, it would increase the score on whether the home team or the visitors team. I have all kinds of buttons mapped out to show the person on base, the number of outs, all of that stuff. And so the top part is kind of the control panel, and then that middle part gets cropped out and overlaid onto our video stream. And so that's how I use programming for sports. It's right there. So if you wanted to do this kind of stuff for ESPN or your local TV channel, you would have that advantage that you could build your own scoreboard right within a game engine. And again, if I take a look at what that looks like, there's some examples of stuff. So, who knows what a variable is? All right, good. I use a lot of them. That's what all that stuff is. And so then I'm using those variables and containers in order to hold people's scores, what team logos are being used, all that kind of fun stuff. And then I spit that out into this thing. Let me open up a more fun project. So remember that attack list that I showed you? And it was just like a bunch of time, date stamps and IP addresses and stuff like that. So that's kind of like boring to look at, just text on the screen. So the chair of that program said, Scott, how can we make this text on a screen look a little bit more exciting? Money. And I said, well, we could kind of visualize it, feed that data into the game engine, and then make it do stuff. So I came up with a universe that there's sound effects too. So what this does is, and some things are not, exactly right. But that honeypot thing in the middle, that's the server that we have running. And then it's really hard to see because of the stuff here. But it's capturing each one of those attacks and then making the appropriate country fire a missile towards the honeypot server. So that's a lot more exciting than just text on the screen. Things blow up, right? Have explosions. That's fun stuff. So we haven't finished this yet, but so far we've defended 13 attacks. And so we could take that data in real time and push it into our game engine and then make it do stuff in real time. How many of you play like a MOBA? Right? How many of you don't know what a MOBA is? Okay, awesome. So in games, let me just stop the explosion. In games like MOBAs, or what does it stand for? Massively Online Battle Arena, right? Multiplayer Online Battle Arena. Where did we? No?
No, no.
Oh, okay. So, like, what's an example of a MOBA? World of Warcraft,
League of Legends.
League of Legends,
Call of Duty.
Call of Duty, GTA, you guys are all over the place, but we'll just go with those for now. So, how many of you have played Rocket League? Awesome. All right, so all of that real-time data through network traffic has to be programmed, analyzed, handled, built within the game app, right? So when you're playing those games, everything's based off of coding. And I'm not the first person to say this, but you'll hear it kind of going forward, is that companies like Ford, Target, Nike, they're no longer like manufacturers of products. They're like software companies. They're interface companies. So the interface that you get in the car that you're going to drive in 5-10 years may be totally different from what you're used to now. Somebody has to program what that interface looks like and how it controls the actual car. Inside of a car, there's actually 30 different systems. All of them are open, and none of them are secured. So if you have a Wi-Fi connected car, that's kind of scary, right? And you've seen examples of how somebody can hack into a car, take control over it, because none of the stuff that's in the car currently is secured. So computer network security, folks, you have a lot of work to do in the next couple of years. And so all of the programming and coding and stuff that I've kind of gone through is relevant for you now. So if you start now, by the time you graduate college, you can pretty much pick the job that you want to make, have happen for you, that you want to make. So I don't want to take up too much time. How am I doing on time?
It's going to take another 4 or 5 minutes.
Okay, cool. So I want to go back just real quick. So we've actually used this game engine tool, which is really specific for making games, and kind of put it into different uses. So we also built a fully kind of simulated house that we call the Trash House. And our child advocacy program, they wanted to kind of take things online. And what they do is the university owns a house behind the university. They literally trash the house with pizza boxes, dirty diapers, uneaten food. It's really disgusting. And then they have a case study for their child advocacy folks, and they walk the people through the house. And these child advocacy folks have to kind of write down and make notes and determinations and then write a paper around whether or not the state needs to get involved with this particular case, or if it needs to kind of go into counseling or some other determination. And how do you take that online? Well, you build a game around it. So that's what we did. And our students built that, and we've been using it for 3 years. And we're just getting ready to kind of take it to the national level, where pretty much all of these other child advocacy programs in the country are going to use the game that we built by my students. So that's really, really awesome. There goes another smart. So using game-specific tools, using any kind of tool to get that result that you're trying to get is really, really, really rewarding, and can be profitable, and it can be fun, and you can meet a lot of really good people connected around what you want to do as well. So I would suggest kind of looking into Unity if you're interested or want to get interested into this, but also learn as much code as you can now, because your brains are set up in order to do that now. Later on, my age, it gets really hard, and I have to relearn things, and that's why I copy and paste code all the time. So I do want to highlight a couple of things before I'm out of here and turn it over to the next folks. But April 4th, we have Aaron Draplin from DDC Design, Draplin Design Company. April 4th at Theater N. He's an awesome logo designer. April 6th, we have a Rocket League competition at Theater N up in Wilmington, which should be open to the public. We haven't really figured out all of the details yet, but we're partnering with Nick and the Microsoft Store in order to have this Rocket League competition. And we're doing all kinds of other things with Nick and the Microsoft Store around gaming. And then April 28th through 30th, we have East Coast Reboot, which is a 3-day tech tournament that includes Photoshop Fight Night, a coding competition, a game jam competition where you have to make a game in 3 days, a game pitch competition. So if you know nothing and you want to kind of just pitch your idea to a game, you can actually do that to folks who make games for a living. And during that time, we have an Overwatch tournament, which is, I think, Wilmington is going to host a couple of different schools from the area to kind of come in and play against each other in that Overwatch tournament. So those are just some of the things that we have going on at the school around our College of Technology. And there's our little webpage to find out more information. So I will turn it over.
It's interesting. My name's Tony Tancredi. I'm the Chief Technology Officer for Diamond Technologies. We're an application software company and a managed IT company out of Wilmington. And you know, Scott and I didn't get together and compare notes before coming here. I never met Scott before.
Nice to meet you too.
Yeah, but it's interesting how my PowerPoint has a lot of the same things his had. Now, we come at it from two different directions. I'm not a game programmer, right? As a matter of fact, I'll admit that I'm an old guy, right? PCs weren't even invented yet when I started, when I was in college. All right, I came up through large mainframe computers, then when PCs came around, started programming then, and then cloud computing came around, started programming all that. So I've been a developer all my life and continue to develop today. Today, though, I'm going to talk a little bit about programming and how it relates to a career. One of the cool things I like about programming, now, I say IT because there's a lot of different things you can do in IT, not just programming, but if you're into hardware, servers, phones, that kind of thing. But it's creative. It's one of the few jobs now, careers, where you can actually create things. It's almost like writing a song, right? Or painting a painting, or building a building. You get to decide how you want to code things. Now, obviously, you're doing it within a framework of trying to solve a problem, but you get to decide a lot of times what colors you want. You know, Scott's thing, he decided to put planes and planets and missiles on his, but you could have decided to do something else. So it's your canvas. You can do anything you want. Now, you're not going to find that if you're a toll collector. Not that they're bad jobs, but a lot of times you don't get to create things, and in programming, you get to create. And it's not just math and programming languages. That's where you're at now, learning programming languages, doing some robot development and things like that, but it's a lot more than that, okay? It's design, it's colors, it's architecture, and it's really cool that way. And you can get creative with even the smallest task. Scott mentioned an if-then else statement, right? Does everybody know what that means? It's just a piece of programming that says that if this condition exists, then do this. If it doesn't, do something else. Well, I might do something a little bit different with it if-then else. All right, so I mean, you can get creative, and that's what's fun about it. And you can usually have 10 different technologists, 10 different programmers trying to solve the same problem, and they're going to probably do it in 10 different ways. And even better than that, I guarantee every program I've ever written, I've gone back into it and said, man, I could have done that differently. I should have done it differently. So, I mean, let's see if I'm still the internet here. So this is something boring. So one of the systems that I wrote last year is for the state of West Virginia, for people to claim unemployment benefits. All right, so what this system does, it's web-based, but it also has a phone component. So people can call in to try to get benefits. They can go into a website to get developments. So it was up to me to decide what colors. Now it's really boring compared to game programming, right? But I had to design it so people with Internet Explorer 9 could claim benefits, right? So people that can't see very well can claim benefits. People who can't hear can claim benefits. But I got to design all that, and what was also nice and cool about it, I had to learn about phone systems, right? So I had to learn electronics. I had to learn how phones are answered, how phone systems work, what SIP is, which is TCP/IP-based phone protocols. I had to learn about all that. How do I handle 100 calls coming in at one time? You know, so it's always challenging. There's always something new in this career. So there's thousands of different options in this industry. What are you passionate about? Is it cars? You can program cars. You can program in the car industry. You can program sales systems so dealerships can process sales and things like that. Anything you can think of, anything that you're really passionate about, you can find a career in programming. You know, if you're, Diamond Technologies, we support a lot of nonprofits, like the YMCA of Delaware, the United Way of Delaware. So they have big IT needs, big programming needs. So if you want to, spend your life giving back, you can actually work for nonprofits and give back, work for the government and give back to the people and get paid for it too. That's the other cool thing. So again, even within those, you have programming, you have servers, mobile, design work, management. I don't know if too many will be managers, but if you do, there's a path for that too. In my role, I'm responsible for the technology vision that comes out of our company, but I'm also responsible for all the developers. So that's pretty cool for me. I mean, I get to manage Scrum meetings, Agile meetings, which are development methodologies, but also I get to learn from all these people. We have a lot of different kind of people that work for us. And technology is very social. So if you like Facebook, if you're always online at Snapchat, all those kind of things, there's communities for every single programming languages, for games, for specific architectures, for specific kinds of programming, like mobile programming. And as Scott mentioned, when I interview people to be a developer, if they don't tell me they use Google as one of their tools, I typically don't hire them. Because there are code samples for every single thing you want to do. Now the hard part, it's all about problem solving. All right, so everybody moans, and I remember when I was in school, everybody moaned and groaned about word problems. Well, guess what? It's all about word problems with programming. And to make it even worse, the person giving you the word problem probably doesn't know what they're talking about or what they really want. Right? So it's up to you to figure out what they really want. And it's up to you to figure out how can I take what they're thinking and make it a program. So one of the things I want you to think about, and you probably think about problem solving all the time, especially if you're playing games. Like, I don't play a lot of video games because I look at a computer all day long, so I don't. One of the things I don't like to do is go on and start playing games. But when I was, what was I thinking? How is that programmer, how's Scott trying to keep me from going to the next level of my game? What is he doing? What is he trying to make this program do? Thinking logically. And how do you figure that out? You keep testing. You're testing the program, trying to find which way it's going to lead you and how to get over those hurdles. So even when you're playing games, you're acting like a programmer. And I want you to think that way a little bit. How is that programmer challenging me, to get through this game? And again, as I mentioned, this problem solving can be applied to anything. Now, what I like to do, some people like to problem solve by playing chess. What I like to do in my spare time is I like to rebuild car engines. I'm also into fishing and boating, so I've learned how to do fiberglass from boats and rebuild boat engines, which is all very technical. It creates, when something goes wrong, I have to figure out how to solve that problem. So there are lots of ways where you can start thinking about problem solving, and it's all logic. Programming is very logical, if, then, else. Yes or no, right? So it's all about logic. One of them, as I mentioned, they didn't have PCs. They didn't have any computer courses when I was in high school, but what they had was logic courses in high school and college. So I learned a lot about logic and different kinds of algorithms and things like that. So I know that's a little bit beyond where you're at now, but I want you to think a little bit deeper when you're doing those programming examples and seeing what it is, because what it's going to help you with. I've been in the industry for over 30 years. I bet you, and I'm sure Scott has too, we've probably developed in 20, 25 different languages, different computers. It's not just the language. The languages aren't hard to pick up once you start thinking like a programmer. An if-then-else is an if-then-else. A loop, where you do something over and over again, is a loop. You just have to learn how to do it in JavaScript, or you have to learn how to do it in C++, or you have to learn how to do it in Swing. Right? So you're going to be learning, whatever they teach, whatever programming languages they teach you now, but the things you learn about architecture will let you do anything, let you code anything, get any kind of job anywhere. So when you're doing that kind of stuff again, think architecture, think how it's built, think why is this thing working, not just how do I do it. This is where Scott and I agree on a lot of things here. So I'm going to give you some of the, I won't say bad things, but some of the things that are required to have a career as a programmer. All right, it's fun to mess around and do things. I thought this assembly might be on IT in general, but you're going to put programming, design, architecture, whatever you want for IT. Does anybody know what meritocracy means? I think we'll figure it out. What it means is you get what you put into it. It's based on merit. It's not based on how smart you are, how good looking you are, or anything like that, how good you smell. It's how good a programmer are you. When I hire somebody, they don't necessarily have to come out of college. As a matter of fact, at Diamond Technologies, we've been hiring programmers out of a program called Zip Code in Wilmington. So there are people who didn't go to college, or they, have had a hard time deciding, you know what, I want to have a career in IT. So they go to the Zip Code program, and for a month, I can't remember the exact number of weeks, they learn Java programming. And now they're starting to learn C# programming. And we hire out of that. And the ones that stick are the ones that work hard, always trying to learn. And one of those things that, I'm 56 years old, right? And you wonder why I'm up here, but I'm a techno geek like a lot of you. So what am I doing on the side right now? For those of you who rose your hand about Raspberry Pi, this is a Raspberry Pi board. This board actually has Windows 10 on it and a gig of memory. So by programming into this, you can do robotic things. You can manage controllers. You can do almost anything. What I'm trying to do, Scott mentioned it, all these devices, cameras, refrigerators, cars, they're insecure. Right? I have a patent on a program that does network security. Never made any money on it, but I have it. So I'm trying to get it to fit on this. And then if I can get it to fit on this, maybe I can get it to fit on something this big. And then it can be put into a camera. Then it can be put into a refrigerator. Right? And then maybe I'll make some real money. But but I like doing those kind of things. So I'm always keep learning. Through my career, I learned how to do Visual Basic programming just as Windows came out. I learned how to do C# programming before C# ever took off. I kept pushing myself to learn because you know why? It's a competition. When you guys get out of here, you're going to be competing against each other to get jobs. You're going to be competing against a whole mess of other high schools to get jobs. You're going to be competing against a bunch of people in the United States to get jobs. You're going to be competing against a bunch of people from India and from China to get jobs that work a lot cheaper, right? So you have to keep sharp. You have to keep your skills up to date. You have to really be into it, and if you work hard and be competitive, you're going to have a great career. You're going to make some good money. So always keep learning. Stay ahead of the curve. One thing that you may want to do that I found valuable is to read trade websites. So if you're into gaming, read the gaming websites, especially the gaming programming websites. Right? I like to read the IT websites and some of the programming websites too, because I learn things. I don't always understand them, so don't ever get bogged down that I don't really understand it. Read the whole thing, then go back and research it. But that keeps you ahead of the curve. And then try new things, as I mentioned, before your boss asks for them, or before your teacher asks for them.
That's it from my side.
So I'm a little bit different than everybody else, but I am probably the glue that kind of holds all this together, which is kind of interesting. So my name's Nick Christine. I'm the Community Development Specialist with the Microsoft Store in the Christian Mall. How many of you guys been in the store? Most of you? Cool. You guys like the store? Yeah? All right. Cool. You guys play the Xboxes in there?
Yeah.
VR? Yep. So my job is basically to give Microsoft back to the community. And I do that in 3 different ways. One is through free workshops. So how many of you guys knew that Microsoft Store had free workshops?
No, I did not know that.
Yeah, right. So this is where I need to do my job better. So only 3 of you knew that we had free workshops. How many of you guys want to get better on your devices and save time while doing homework? Right? So most of you? So we have workshops around Office, which I know doesn't sound horribly exciting, but what if I could tell you I could save you time on doing homework so you can do the fun things that you like to do? Right? Yep. Same thing with the educators. So your teachers, we've got different things that we can offer them too as far as classes and work with business folks. So we work with Diamond Technologies, we work with Scott. So most of the stuff that I teach is more on the user end. You guys like working with people? Any of you? A couple of you? Yep. So that's the part that I really like about my job, is that I get to work with people in teaching you all how to use the technology. So more on the user end, they're more kind of the behind the scenes guys doing all the coding and programming. But I actually get to do a little bit of coding too. So I work with a lot of different nonprofits and schools in teaching schools and school kids how to do coding. So that block coding is very much what we teach, and we teach that around Minecraft. We've got some of our own Microsoft coding applications that we actually teach JavaScript. So I get to do a little bit of that as well. So we did, like I said, do 40 to 50 hours a week of free workshops. If you guys are interested, you simply have to go onto our website, Microsoft Store/Newark, and sign up for our classes. So, and next month in April is going to be all education. So anything you guys want to learn about becoming more proficient with your devices, that's going to be the month to sign up. The great thing too about our classes, you may say, well, I'm a Mac guy, you're from Microsoft, you can't help me. No, we've got Microsoft classes for Mac users, and for Android users, and for iOS, the whole works. So we are cross-platform that way, and we're happy to help any way we can. The other great thing that I get to do is sponsorships and donations. Anybody have any idea how much money Microsoft gives away as far as Microsoft philanthropies? Let's hear some guesses.
$1 billion.
Yep, nailed it. So Microsoft gives over $1 billion a year away in philanthropies, and that's both in services. How many of you guys knew that nonprofits get $5,000 worth of services for free? Did you guys know that? Yeah. So Office 365, Azure, the cloud, nonprofits get $5,000 a year of that. So we actually help them with that implementation, work with partners like Diamond and Wilmington University in kind of doing that kind of fun stuff. But in addition to that, I also give from the retail side. So I get to give away product and monies to different nonprofits. So we support folks like the Boys and Girls Club, Zip Code, Open Bracket, which is a coding competition and things of that nature. So I have the great fortune of doing that. And then lastly, I'm the volunteer coordinator for the associates. So we have 34 associates. We are the only 34 Microsoft employees in the whole state of Delaware. But we volunteer once a month for different organizations. So the SPCA, Boys and Girls Club, Hagley Museum, Salvation Army, to name a few. So we're constantly looking for folks to partner with and to volunteer. So really, my side of technology is very, very different than their side of technology. But any idea what you guys want to do for a living when you guys get old? How many have you guys figured out what careers you want to do? A couple of you? How many of you are unsure? Whole bunch of you. How many? So what degree do you think I have? I'll give you a hint. I have a bachelor's in science. Nope, not computers. Not a doctor. What do you think? Nope, not coding. You guys aren't even close. I definitely have a bachelor's. What's that? What's that? Bio, like biology? Close. I'll give you a hint, I'm standing on it. Nope. What's it made of? Wood. Where's wood come from? Trees. What do you call a bunch of trees? Forest. I have a degree in forestry. And I work for Microsoft, which is almost an oxymoron, like how on the earth does that possibly work? But I tell you that not because, I want to impress you by any stretch of the imagination, but I want you to know that no matter what paths you choose, like that doesn't have to be like the place that you stop. Like if you go to be a doctor, if you go to be a lawyer, like you don't have to be a doctor, you don't have to be a lawyer. I love the outdoors, so that's where forestry kind of came in, but I also have this gigantic love for technology, which is why I work for Microsoft. And I love working with people one-on-one and kind of seeing that light bulb go off in people's heads when, hey, I can show you something about Word that's going to make your life really easy. I can show you how it's going to make your citation page for you automatically. You don't have to worry about it. So now you've saved yourself a bunch of time. Just that light bulb going off where you come to me and say, hey Nick, looking for this device. Can you help me? Yep. This is the perfect device for you. This is going to make life a lot easier. So, like I said, I have a very different kind of role here in technology, but I tell you all that too, to know that you can do all kinds of different things with technology. And I get to do pretty much what they do on a kind of a smaller user end scale. So, thank you.
Thanks, Mr. Nick, for trying to pull all this together.